Okay, so our next question is perfect square. So perfect square is basically a square of a number given to you. To explain you more about this, let me delete this title first. And let's say you have given 121 number. Okay, now you will be asked to check whether the given number is a perfect square or not. So as we all know that 11 square is 121. So 121 will be the perfect square for the number 11. Okay, now let's say you have given number 123. So it will nearly, the square root will be nearly equal to 1.10 or something like that. So it is not a perfect square. It is as simple as that. So what I will do, we will directly jump to the pseudocode section and show you all the different ways that are there. Okay, now let's see. In C++, there is a CMath library which is implemented, and all the mathematical related functions and executions are done there, and you have been exposed to all the functions. And in that CMath library, there is a function called square root. Using the square root function, we can directly take the square root of a number. Okay, now let's see how we can use it. So I'm just going to give the pseudocode here. So let's say you have given a number 121. Okay, now what we will do, we will store the variable, that is the value, square root value. So let's say srt, which is square root equal to sqrt. So square root is the function which is available in the CMath library, and we can directly pass the value to the square root function, and it will give the double. It gives the double value, okay, which is not an integer value. So what we can do, we can initially check if when I multiply it. So square root is basically the original number that is given to us, right? So we need to calculate the square of it. So what we can do, we can directly multiply it by itself. So SRT into SRT is equal to my original number given. So this is my original number, and we will check if my square root that is calculated is equal to the original number. Then what we can print, we can directly print that the given number n is perfect square. Okay, and in the else section we can say that the number is not a perfect square. So number is not perfect square. Okay, now another approach is to directly do the one thing. Okay, so let's say we have a number n equal to 1. So this is the solution 2. This is the solution 2. So let's say we have a number n equal to 1. Okay, now there is a concept called floor and ceil. So whenever a floating point number is given to you, when you write this function floor and ceil, it gives the, see what floor does is, let's say you have given a number 2.3. Okay, so let's say you have given number 2.3. So floor of 2.3 will give the value 2. Okay, that is the base value. And as you can see, the name itself suggests it will give the floor value, the base value, and the ceil of 2.3 will give the uppermost value, that is 3. Are you getting it? Now if a number is an integer, so floor of an integer number is equal to 11, and ceil, that is for floor of 11 is equal to 11, and ceil of 11 is also equal to 11. So what we will do, we will check if my floor of the square root, because we need to calculate the square root of a number. So we will need to calculate square root of a number, let's say n, okay, is equal to the ceil of square root of a number. Okay, now we might need to convert it into a double and float according to the data types that are available, and we can ultimately check this thing. So if floor and ceil is equal, then we can say the number is perfect square. Okay, else it's not. Okay, now we will check whether we need to convert this into the float or double or like that, okay, in the actual code. So let's try to incorporate into actual code. Thanks for watching. Okay, now let's code the perfect square problem. So here I have declared a variable and taking the input from the user. Okay, now the thing is here what we need to check, if let's say 11 square is 121. So to check whether 121 is a perfect square or not, we will calculate floor of the number. See, what is the square root of 121? It is 11, right? So if you calculate floor of 11 and seal of 11, it will give exact number, that is 11. So floor of integer number and seal of integer number always give the same result. And if let's say we have something like 3.14, so floor of 3.14 will be 3 and seal of 3.14 will be 4. Always keep this in mind. So both the numbers are different, so the condition will fail. That's why I have declared or written here, if floor of square root of number is equal to seal of square root of number, if it is there, then we can print that number is a perfect square, else it is not. It's just that simple. So let's create a problem and let's give input like 121. We know that 121 is a perfect square, so we got a perfect square. So let's say 44, is 44 a perfect square? No, it's not. So we know that 4 is a perfect square of 2. So if you try to run it, it will give perfect square. Okay, so it is running perfectly fine. Now it's your time to do the code. Thanks for watching.